So again, just to recap. First of all, to solve transportation task in Excel, you have to prepare one of the recommended layout. Here is given one layout, which is given an example. During lecture, I present a little bit different layout. Actually, during lecture, I present two layouts, this one and another. So it's available few ways to complete this. As I already said, here in resources column, we place our table 1 data, resources at warehouses in uniform units. And at row request, we provide our real request from table 2. I mean, speaking about your task. Of course, again, your version will be larger. You will have extra real pharmacy and extra real warehouse. So again, by color, I made selection only for those items which are real. And actually, we have the same things. So here is it's just visible formulas I show for you. Then, once we place this, we have to check feasibility condition. For this, we have to summarize our real resources and real request, real demand. Here is given formula. At this worksheet, given results. And as they don't match, so our feasibility condition has been broken, and we have to introduce dummy object. Which one? In this case, resources smaller than request, so we have to introduce dummy imaginary warehouse and provide imaginary resources. Of course, it can't be delivered because they don't exist, but we have to provide this. Also, we have to build two matrices. So here is this one is cost for transportation cost. And here we have our future transportation plan, which is, again, as you can see, also I have added dummy object. I have added dummy transportation cost, which is obviously 0. And here we have our future transportation plan, our objective. Right now, it must be filled with 0, and later Excel spreadsheet will fill it for you automatically. So then, where do we have? Okay. Here we have to provide necessary formulas. Summarize our flow out, summarize flow in. Right now, all this, of course, will return 0 as well. And prepare objective function. Does we have this? Oh, look like I lost my formulas there. Does it correct document? Wait a second. Yeah, that one is correct. Just for some reason, I lost formulas. No problem. Let me add this. So here it is. And here comes above. It should work this way. So now everything's correct. Then objective function. An objective function is multiplication of two matrices. And here is check order. We multiply cost matrix per plan matrix. Order is important there. If you remember matrix algebra from Lyceum, I think. And then actually almost everything done. Then we should provide constraints like this one. So for example, here is, sorry, it was not necessary for me because I have done it there. Okay, it's the same constraints, A, B, C, D, like there. Really no necessary there and not necessary there. It could be placed there, no problem, but here is, I place it in this case. Here. Okay, and when you, again, all this formula will return 0. When you've done this, the question will be only to run solve. And only one important point. What if we will have opposite case? Like imagine our request, this one, and our resources, so opposite case. In this case, you have to provide not dummy warehouse, but dummy pharmacy. Introduce column, not row. And this case not considered in example because it's actually easier than this one. But it's spoken about this. It's spoken about this here. Here at the beginning of page 24. Keep in mind this point because different variant contains different things. So let me delete unnecessary things. Once you do it, prepare your solver. So first of all, you should provide self-objective function, actually which your objective function contains. Then goal of optimization, minimum. We want to get minimum transportation costs, so we want to get minimum to this. How we can achieve this? By changing our transportation plan. We can change delivery cost. It's constant, it's given. So we change our transportation plan. And then constraints. First constraint spoken that result must be integer. It's assumption from task. So again, we are talking general task, and in reality, we have not uniform goods, but it's easy to bring to be uniform, to standardized form. It's we replace packages, for example, with weight or volume. And after that, we get this standardized unit. It's actually the way which any delivery company manage with these things. So then, list of constraints. It's actually first forespoken that our flow out must be equal resources, and next for that flow in must be equal request. Nothing more. So we also ensure that our results will be positive, not negative, and we have to use simplex linear programming method, not nonlinear. Okay, that's all. So, and here is Excel give you solution. Excel give you solution. You can accept it, you can solve, you can save scenario, repeat with different parameters, and so on. So actually, it's spoken about how many items have to be delivered from particular warehouse to particular pharmacy. The only issue with this plan that this one, it's imaginary item. So this one pharmacy will not retail all that they want because it's not available. But speaking mathematically, it's optimal solution. In example, given recommendation about possibility to improve solution with equalization of that undelivered items or so, but it's not necessary to be done if you want. So that's actually all things I want to show for you. Do you have any question about this?
No.
I think it's enough about recording. Yes.